everyone, and welcome to today's video of distance and midpoints. Now this is a unique section in geometry in that it is completely algebra based. We're still working on how things relate to each other and why they relate to each other, but we're going to be using a lot of our algebra skills, particularly fractions and radicals. Don't worry, we'll go over them as we get to them. But let's go ahead and get started. Now distance is the length of a segment between two endpoints. Okay, it is how far one point is from the other. And because we're measuring distance, because we're measuring how far something is, we don't really care about negatives. And what I mean by that is you're never going to travel a negative distance. Okay, you can go backwards all you want, you're not going to go a negative distance. So even if after you do algebra you get a negative number, what happens is we put that equation, that distance, into absolute value. And that absolute value gives us the regular number. Now let's do some examples. So I'm going to use this number line to find the measurement of BE. So B is all the way over here. All right, and E is all the way over here. Now you can count. This is an easy counting. So this is -6 plus 2. The measurement of BE is going to be 8. And if we were to put that in the equation, so we didn't want to count, well, we have -6 minus 2, which is a -8. But because it's absolute value, it spits out the positive 8. Doesn't matter which way you flip it, it's always going to end up being this. All right, go ahead, try to find the other ones. You can count, you can use the equation, either one. Video's going to pause. When it plays again, you'll see the answers. Notice for the first two, AC, CF, you were going from left to right. But on the third one, FB, well, you went from right to left. But that didn't affect the distance. Okay, so keep that in mind. The distance will always be an absolute value. It'll always be a positive number because you'll never have a negative distance. Now here's the promised distance formula. Whenever we talk about distance formula, we're referring to this. And what it does is it takes the last concept and matures it to a geometry level. Please make sure you have this in your notes. This will come back all throughout the year. Now, distance formula actually comes from the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. So a is the measurement of this one, b is the measurement of this leg, c is the hypotenuse. And so what you can do is you can rewrite this and actually say, let's see, we have bc squared. Oops, that's bad. All right, so we have bc squared plus, that's ac squared is equal to ab squared. And I'm still in Pythagorean theorem. I just rewrote it with the names of the triangle. But I don't really know what these measurements are, so I need to find a way to do that. On the last slide, we talked about how it's the distance between the two coordinates. So let's substitute. Let's take these equations and plug them in for our letters and our segments. So now I have x2 minus x1 squared plus y2 minus y1 squared is equal to AB squared. And I'm going to take AB and I'm going to put that back as C. And you'll see in a minute. Ha ha ha. Or maybe you already do see. Maybe it's already starting to look familiar. Okay, so I'm looking for C. I'm looking for the measurement of C. In order to do that, I take the square root of both sides. If you didn't see it earlier, hopefully you see it now, because now I have C is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and here's our distance formula. So this random equation with all these weird square roots and squares isn't so random after all. It comes from Pythagorean theorem. So if ever you forget, you can start at Pythagorean theorem and work your way over. Now that we've talked about the formula, let's do some problems. I'm going to rewrite it. We have, I'm going to use D for distance. Why not? If you want to use C, go for it. x2 minus x1 squared plus y2 minus y1 squared. Now, the little 1s and 2s, what that indicates is that there's more than one x. Okay, so you have x1, you have x2. There's two x values. Because of the coordinates, because of the numbers, it's easier to label stuff, x1, y1, and that way it kind of cuts down on your just copy errors and prevents you from mixing things up. So then I'm going to take this, I'm going to just plug it into my equation. So I have 7 minus 3 squared plus 2 minus 4 squared. And once you have it plugged in, it's just algebra from here. You can solve this. 4 squared plus negative 2 squared is 2. 8 plus 4. And that means that D is the square root of 12. Now don't think you're done just yet. We have a radical, now we have to reduce it. So I take my 12, I bring it off to the side, that's 4 times 3. Well, the square root of 4 is 2. 3 stays on the inside. So my distance is truly 2 root 3. And this right here is my answer. All right, so this is the process. You're going to take your coordinates, you're going to plug it into your equation, and simplify as far as you can. Sometimes you'll get a perfect number. Other times you'll get a radical that can be simplified. Other times you'll get a radical that can't be simplified. But don't be scared off. As long as you plugged in and did the math right, you did a good job. All right, your turn. You do the other two. Now in this one, I'm going to show you something real fast. Notice how when I did my x1 minus y1, I have negative 5 plus 4. Okay, don't forget that you don't have negatives. You don't subtract negatives. If you have negative 5 minus a negative 4, this just becomes a plus. So negative 5 plus 4. Because what happened was you had your parentheses and the negative distributed in. Okay? Anyway, there's your answer for the next one. Try the last one. And there's the answer to the third one. Now I'll save you the trouble. The square root of 58 does not simplify any further. So that would be your answer. Now we move on to the midpoint formula. Now midpoint, again, we're on the coordinate plane or we're on a number line. Midpoint is the exact middle between the two segments. We talked about this last lesson. It divides the segment into two congruent pieces. On a number line, you're just, again, you can count, or the equation is just a simple average. You take the two endpoints, you add them together and divide. On a coordinate plane, you get a much more interesting equation. Now make sure you have this equation down. The one thing I really want to point out is notice the comma. This is not just one big equation, it is actually two really small equations, the average of the x's and the average of the y's. We're going to use this idea in the next slide. So here we are, let's do some problems. The first one, find the coordinates of M, the midpoint of ST, for S is negative 6, 3, and T is 1, 0. Now sometimes the word problems they can just be alphabet soup. It can jumble in your brain, doesn't make sense. So even if you're not in the right quadrants or in the right coordinates, and if your graph looks absolutely awful, sometimes just drawing it out. Okay, this is S, this is T, that means M should be in the middle right here. Even a quick sketch like this at least helps you orient where your points are, which can be helpful sometimes. So I'm going to make this x1, this y1, this x2, and this y2. By the way, if you're changing these, if you flipped them and had S be x2 and y2 and T be x1 and y1, that's totally fine. You'll get the same answer either way, even on distance formula. If you swap the points, nothing happens. Just make sure that you stay consistent. Okay, so if this is x1, then this needs to be y1. All right, so we have x1 plus x2 divided by 2. And then we have, sorry, technology problems, y1 plus y2 divided by 2. Here's our equations, now let's use them. So we have, that's going to be negative 6 plus 1 divided by 2. Negative 6 plus 1, that's going to be negative 5 over 2. Don't be scared of fractions. They're your friends. Leave them alone. Now we go to the y's. We have 3 plus 0 divided by 2. That's going to be 3 halves. Again, leave the fractions alone, which means that m is going to be negative 5 over 2, comma 3 over 2. And that's it. The average of the x's, comma, the average of the y's. Your turn. Do 4a and 4b. And here are your answers. Now notice how I formatted my answers. Each answer is a point. Okay, it's an ordered pair. It is two numbers with a comma and parentheses. If you're given ordered pairs in the question, you need to have ordered pairs in your answer. Now clearly, if it's a number line, you don't have a y. You only have the x, so you don't need an ordered pair for a number line. But in all three of these problems, you're given ordered pairs, x, y coordinates in the problem, so your answer needs to have an x, y coordinate as the answer. All right, now, on the last slide, I mentioned it's sometimes helpful to draw a picture. Here's why and where this becomes really helpful. So we're going to find the coordinate of j if k is the midpoint of JL. So I'm going to draw my line. Again, I'm not really caring if it's in the right quadrant or even going the right direction. All I want is the orientation, because k is the midpoint. K is what we have. We're trying to find what j is. So this is going to be negative 1, comma 2, and this is 3, comma negative 5. We're looking for x, y. The way you solve this is the same way you solve the other ones, only you're going for a missing piece. Instead of looking for the midpoint, you're looking for the x coordinate. So you label them like always. This is x1, this is y1, x2, y2. And this is my midpoint x. So I'm going to take that equation, and I have x plus 3 divided by 2 is equal to a negative 1. Okay? Because remember, the equation was x1 plus x1 plus x2 divided by 2 is equal to the midpoint's x. So you could call it midpoint x. Or, if you wanted to, x sub m. Doesn't matter. We have our coordinates. Even though one's a variable, that's fine. As long as you have only one variable in the equation, you can solve. Multiply both sides by 2. I have x plus 3 is equal to a negative 2. X is equal to a negative 5. You do the same thing for the y's. Y minus 5 divided by 2 is equal to 2, because here's our, m sub y. Multiply both sides by 2. Y minus 5 is equal to 4. Y is equal to 9. And so your coordinate point is going to be negative 5, comma 9, and that's what j is. All right, so this is why drawing the picture is helpful, because oftentimes we get into a habit of, oh, hey, here's midpoint formula. Let me just toss all the numbers in. No. Draw the picture and confirm whether or not you're given the endpoints or whether you're given an endpoint and the midpoint. That'll save you. All right, do the next two. See if you can find them. And here are your answers for the other two. On 5b, we had an answer of negative 7, 0. Okay, don't be scared if you have a 0 in a number for one of these. 0 is a coordinate for both the x and the y. How'd you do? All right, last one. Midpoint formula with expressions. So we've done number lines, we've done coordinates where we're given the endpoints, coordinates where we're given an endpoint and a midpoint, and now we have a segment with expressions. When you're dealing with these, the midpoint formula is useless. The midpoint formula is only for when you have coordinates. We no longer have coordinates, so it's useless. When you're doing these problems, you need to remember the definition of midpoint. And the definition of midpoint is that it divides the segment into two congruent pieces. One more time, two congruent pieces. Okay? And those two pieces are equal to each other. So whenever you're doing problems like this, you can immediately, after drawing your picture, take the two pieces and just set them equal to each other. Okay, so let's go over here to our problem number 1. It's not labeled, so I'll label it for you. Problem number 1's over here, guys. Here I'm told that PQ, find the measure of PQ if Q is the midpoint. So that means that this piece is congruent to this piece. Make sure you get in the good practice of drawing your congruency symbols, guys. So since they're congruent, I know they're equal, so I can set them equal to each other. 9y minus 2 is equal to 14 plus 5y. And now I solve. 4y is equal to 16, y is equal to 4. Now on these problems, make sure you read the questions. I am looking for the measure of PQ, which is this measurement right here. So I'm going to plug in, and I have 9 times 4 minus 2. 36 minus 2 is going to be equal to 34. Make sure you really pay attention to the instructions. Sometimes it'll ask for X, sometimes it'll ask for you to plug in the segment, sometimes you gotta go 2 more steps afterwards. Always, always, always read the question carefully. Okay, now on these two, it really does help to draw the picture, just like we did in the other ones. It just kind of helps you orient yourself. So find the measure of YZ if Y is the midpoint of XZ. So here we go. Here's X. Here's Z. Y is in the middle. Draw your congruency markings. Next, we know that XY is 2x minus 3, and that YZ is 27 minus 4x. Okay, so we're given the pieces. Because this is a midpoint, I know the pieces are congruent, and therefore they are equal. So you're going to take these pieces and set them equal to each other. And there we have x is equal to 5. But reading the question, we want the measure of yz. So we're going to plug in, and I have 27 minus 4 times 5. 27 minus 20. Yz is going to be equal to 7. All right, your turn. Go ahead and do 6b. How'd you do on this one? Hopefully you remember the definition of midpoint. Midpoint means it's cut in half. Half means you have 2 equal pieces. So if one of the pieces is worth 4x plus 5, that means they're both worth 4x plus 5. So you either could have added that together, or you could have multiplied the one piece by 2 and set it up like this. Now normally I want you to leave it as an improper fraction. Improper fractions are superior. They just are. But for this one, if you got 8.5 as your decimal, you did it right too. All right, guys, this is it for the video. Let me know if you have any questions next time I see you, and have a good one.